Hello everybody, it's Alex, and this video is going to be a very important video. I'm going to be outlining everything that I did in my whole electrical engineering degree. This is what £60,000 looks like in terms of education. I'll be going through every single module that I've done, and yeah, with the content of it, and I'll be doing my best to show you examples of what I did of my work. And if I can't find my work, then I'll try to give you an example from the internet somewhere. And just like a point of notice, most electrical engineering graduates in the UK for the most part have a very similar course, and I would say even in the US it's very similar. When someone says that they've done an electrical engineering degree, it's everyone knows what you've done, if that makes sense. So it's a really good standard education. Everyone knows what you've done, everyone knows who you are. So yeah. Let's get into it. First year, we start off core maths 1 and 2. I'll put those together. First semester, I remember going through matrices. I remember going through calculus 101, differentiation, integration, like the basics, more stuff like A-level content. I also did complex numbers. Very important, fundamental maths. Core maths 2, I remember doing more integration. I remember also doing stuff with like root mean squared, and I remember doing ODEs. We also did stats. We did binomial distribution, set theory, probability, stuff like that. Next is programming and software design. This is a module which in essence introduced me to C. I can actually show you my first ever C code that I've ever written. To this day, I don't claim to know how to write C. I think it's an extremely difficult language. What did we do? I had an introduction to data structures, variables. That was a difficult module. I did have experience in Python, but C is just a completely different world. I think very useful. I think every electrical engineer should know how to code a bit in a low-level language, so that was very useful. Next module, electronic circuits. This is a super heavy module. I think the first module in first year, which for the most part was completely fresh. And it started off obviously with the basics, with Ohm's law, which I hope everyone knows what Ohm's law is, Kirchhoff's law, but then you go into like star delta circuits. We also did Thevenin and Norton's theorem, which was really big. Mesh and node analysis, semiconductor physics, NPN, PNP. We were introduced to BJTs, bipolar junction, transistors, and then the other ones were FETs, FETs. Yes, we were also introduced to Xenodiodes. I can't lie, guys, I don't remember much from that. It was very heavy, a lot of content. I felt like I was learning electrical engineering, so that was a really good module. Lots of lab work. Fun fact, let me tell you a cool story. In my this was the first module, my first ever lab. We were learning how to read resistor values. Fun fact, I am colorblind, and when I went to the lab, the way you read a resistor is via the color on the resistors, and the combination of the colors tell you the resistor value. I just couldn't do it, and yeah, it was just a funny moment when I realized, damn, I just can't do this lab, it's impossible. And so I got to cheat and use an oscilloscope to find it. Yeah. Now, electrical science A, as the name suggests, it was more on the physics side of things. We got introduced to Faraday's law, to Ampere's law, to Lorenz's force. I'm kind of surprised because we didn't really have the maths fundamentals properly to do this, but that's what we were introduced to. I remember the lecturer using this magnetic simulation software called the FEM. I also remember covering power and the different types of power. You've got active, passive, complex, apparent power. So all those things were also introduced, and it was very heavy on the exam, so there wasn't much lab going on, but there were some simulation stuff, but yeah, it hasn't really stuck. Digital systems, really good module. This is kind of like a blend of the computer science and electrical engineering. So what did I learn there? I remember there was a coursework to create a 7-segment display. There we were introduced to digital versus the analog world. We were also doing some signal processing. The Fourier series and the Fourier transform was first introduced to us. but we didn't do it in maths. So it was a bit mad, I ain't gonna lie. Seeing Fourier series in my first year without actually doing it in maths was wild. And we were also introduced to the binary system, logic gates, truth tables, Carnot-Hue maps, De Morgan's laws, all of that stuff was in there, like the computer science stuff, A-level computer science in essence. That was really good module. Shout out to the professor, she was a lovely lady. And the last thing was a group project. Now, I have a bit of a unfortunate experience with a group project in my first year because it was COVID. So in essence, the highlight of it was presenting a PowerPoint online. So it wasn't even proper. That's it. I actually can't speak about it. I don't remember anything from what happened. All I remember is that there was a PowerPoint. So yes, COVID kind of killed my first year from that perspective. Second year, additional, it was called Advanced Maths 1 and Advanced Maths 2. That's when things started getting serious. And now, the jump between year 1 and year 2 at university, I personally feel like is the biggest academic jump you will ever do in terms of difficulty. Much bigger than GCSE to A-level and much harder than year 13 and first year of uni. Year 1 to year 2, crazy. Now, this is where the maths started getting spicy. Eigenvectors and eigenvalues, okay? And then the implementation of matrices in that world. We were introduced to second order ordinary differential equations. Oh, another thing, there was something called complementary functions and particular integrals. And these are the two big ones now. So Advanced Maths 1, we were introduced to Laplace and Fourier series, Fourier transforms. This is a game changer. If there's one thing you should not sleep on in maths for your electrical engineering degree, it's those two subjects. Laplace saves you when you start doing control, which I'll get to very soon. And Fourier saves you just in general throughout your electrical engineering degree. It's everywhere. You can't run away from it. Really get the idea across that you can switch from the time to the frequency. You get me? Don't sleep on that. Very important. And I would say it was challenging. Yeah, it was challenging. Yeah. Advanced Maths 2 just adding a bit more to it. We were doing complex Fourier series and transforms, and it was much more heavy on the stats. So we did Poisson distribution, normal distribution. We weren't introduced to this, by the way. What am I saying? We got it. Next big module, communications. This is good because I have a lot of work on my computer from communications. There was a lot of lab work, so I had to document things. Fun fact, the labs were so wild, I started just taking pictures of everything on my lab bench so that I could just try and remember when I write up my lab report. One big thing about that module was learning how to use a spectrum analyzer. The spectrum analyzer basically shows you signals in the frequency world, which is very, very useful. This is why we learn Fourier, because it's basically doing Fourier for you and shows you harmonics of different signals. Another big thing that was introduced was transmission lines. Basically, transmission lines are very long cables. What happens to voltages and currents? How do you model them when they're 25 kilometers long? Kind of funny things happen. You can't just treat them with V equals IR. There's actually a very big formula or big theory called telegrapher's equation, which explains the fundamentals of that, which I remember very clearly. Look at that telegrapher's equation. That is transmission lines 101. And another big thing which I enjoyed so much was filters. Filters, low pass, band pass, high pass. Yes, that is really, really cool. And it shows you kind of also where if you add more like capacitors or inductors, you can make higher order filters which have steeper filtering curves. Very useful for audio stuff. The application is actually to what I'm doing here on YouTube. When I'm editing a video, I could throw a little low pass filter to get the low frequencies out of the way. Next was control system design. So remember that Laplace that I was talking about. This is where it all comes. If you don't get Laplace, you don't get control. The whole of control is to design systems. It can literally be any system. It's very useful to have decent physics. We used a lot of mechanical examples in control because I feel like control is more suited to the mechanical engineers. but there's a lot of systems in electrical and in general electromechanical, and yeah, it's a proper, if engineering was a module, this is it. The most engineering module. It's systems engineering. It's thinking about how things interact with one another, keeping things stable. What exactly do you learn? Simulink. You learn how to use Simulink. It's a bunch of blocks that tell you how a system works and what you need to do to keep it stable. You talk about first and second order systems, pole placement. It's interesting stuff. It wasn't my cup of tea, but it was very, very useful. Every engineer needs to learn that. Thumbs up. And in my final year, I actually got to extend this, so I'll talk about that a bit further because I had a really cool coursework, and yeah, I'll talk about that in a second. Electronics. Big module, 20 credits, just full of electronics. The big thing that was introduced there was an operational amplifier. Yeah, if you have two resistors and an op amp, you can multiply a signal to make it bigger, make the amplitude bigger, which is very, very good. The concept of noise was introduced because if you have a signal and it's got some noise, it makes it 5 times louder if you have an op amp which multiplies by 5. So that's where the filters come with from the other module. You know, everything starts clicking together. Negative feedback was also introduced there. ADCs and DACs, analog digital analog converters. They are everywhere. We were also introduced to FPGAs and VHDL. I wouldn't say we were introduced to FPGAs. They're more just VHDL. I can actually show you an example of something that I wrote. It's unfortunate because VHDL is so difficult in my opinion. We didn't have enough of it. I wish I knew more in the world of like RTL design, FPGAs, VHDL, Verilog, all of that stuff. And I remember also learning about memory, different types of memory like ROM, RAM, and EPROM, and all of that stuff. But yes, very, very good and very important module. Electrical Science B. Wow. My favorite module, or half of it, it was split in half. It was split to electromagnetism and power. Half of that module, amazing. The other half, I really disliked. I think it's to do with the lecturers. So the first half of it was to do with power networks, single phase and three phase systems. The whole concept of complex power was there again. And yeah, power networks. I don't remember much of it because it just didn't stick in my head. But the other half, electromagnetism, fantastic module. It was a physics module. Do you know what I'm saying? When I started the module, for the first 2 weeks, we were just learning maths for it because it was like that. So what did we do? We did electrostatics. We did magnetostatics. We did Maxwell's equations. That was it. But that's what runs the universe. So that's why it was so interesting. If you go down to first principles in electrical engineering, somehow Maxwell's equations are there. So it's always good to know what's going on. It's, I think, the most difficult thing to do for electrical engineers because it's so it's physics, and we're not accustomed to that as much. So the lecturer did a really good job trying to dumb it down and be like, you're an engineer, you are not a physicist. In my second year, I also had a robotics project. This was a group project, really good. I have a video or two even about working on this robot. I will show it somewhere here. In essence, we received like a bare bones microcontroller with some servos to move around, and the final product was a robot which could dance to some music. There was some basic cool tech around it, but overall, really good experience, much better than my first year when we just had to present. At the end, there was a robotics competition where, yeah, as the name suggests, there were teams competing, and I don't know if there was a prize, but you definitely got a thumbs up from the professor running it, and it was fun. Robots are fun. Robot competitions are fun. Yeah, like you can't complain about a robot competition project. So yeah, big up. Final year is where it's at. This has obviously just happened. We start off with management, law, finance. Yeah, terrible. I know, terrible. But it has to be done. In England, at least, I know it has to be done because without it, you can't become accredited. So that's why it's there. Law, the laws behind starting a business, how to treat your employees, health and safety. all of that stuff. Accounting, oh wow, profit and losses, balance sheets, them things there. That was probably the most difficult part. Making engineers do accounting is terrible. The amount of men that were complaining about that is crazy. So many people struggle in that module. Like that exam, 100% exam as well. Ugh. What else did we do? We did project management, which I think is, out of all of the things that we did, was fine because I was exposed to it during my internship just naturally. So that was pretty easy for me. And that also quality was a big thing. But yeah, just be aware that you're going to have to do that in your final year. I think it's okay. It's not that bad, but it is pretty dull and so much information that gets thrown at you. If you think about it, there's whole degrees that cover this stuff and you have a 10 credit module running through everything. Mad. Now, the modules that I picked. So I went in my final year programming heavy, embedded route specifically. I picked embedded system design and implementation. I'll show you the coursework for this. Courseworks, these were 2 courseworks for this. First of all, we started off with C++, introduction, object-oriented programming, polymorphism, encapsulation, inheritance, using the features of C++. Really, really good stuff, especially for me. I only knew Python. So for me, this was proper learning. As soon as we learned the fundamentals of C++, we had a coursework on it to kind of create like a simulated environment of a temperature and a humidity sensor working in a room. It got the job done for learning about basic features of C++. Next, our second module was embedded system design and implementation, meaning you get a paragraph from a client. You have to design the software using UML and write the code on an STM32 F3 microcontroller, run it. To show you the coursework, there was some data that had to be processed. Depending on the processing, different lights show up. But the big thing there was designing the software in a UML fashion. I've never done it before. It's a really interesting way of thinking. It makes programming super easy once you've done that. So I suggest everyone tries that out if you don't cover it at uni, because it's pretty much it's a game changer. It completely opens your mind, and with that you get introduced to design patterns. It gets so deep. Next was control. This was state space control. The aim, I remember, of that coursework was to be able to balance a reverse pendulum. So you have a reverse pendulum and it's trying to fall, and you've got something to control that to keep it in balance. That was the coursework. Now in my second semester, I had cybersecurity for embedded systems. So now we had the STM32F7 and we were using STM's cryptographic features. We were using cryptographic algorithms like AES, XTEA, encrypting some data, decrypting it, sending it over. We had even like a simulation type of coursework, sending information from a drone to like a house or like a base station and there and back. Also very, very cool. This was written in C. On the same microcontroller, there was a whole nother module on running machine learning models on an STM, and specifically running. We weren't training machine learning models on the STM board. We were running them and seeing how they perform. Pretty much running timers on the machine learning models, see how long it takes, comparing them, talking about the different, how like optimization on an STM helps a machine learning model perform in the constraint environment. Yeah, we were using like compilation, optimization. It gets pretty fancy, but it was a cool module, but it was a bit mundane because as soon as you have the infrastructure in place, you're just putting timers. You're also looking at memory, how much memory the machine learning models used. Yes, that's basically what was going on. The final thing that I studied was microwave comms. Maxwell's equations were definitely there. We were introduced to the vector network analyzer. We were introduced to antennas, different types of antennas, how they work. It's pretty cool because you know that like TV antenna, they're called Yugi Oda antennas. I think it was just a funny name, and now I know why it looks the way it looks. Oh, I know what I learned there. I got introduced to scatter matrix, scatter parameters, having basically like a black box for an antenna to identify it so that when you buy it, you know exactly how it operates. That was pretty big. And it takes some time to get used to. I remember also studying flow diagrams. I can't remember exactly how they look like, but it was like a specific application of graph theory. Hold on, let me just verify that. System flow graph. Signal, that's what it's called. Signal flow graph. It's like a simplification method for in the world of communications. Have a look at it. I think it's interesting, but I don't think I'm ever going to use it in my life. Unless you're like an RF engineer. The big thing that we all wanted to hear about is my final year project. This is massive. This is 40 out of your 120 credits. I did my project with the title of Application of Graph Neural Networks to Simulate to the Airflow in the Lungs. Wow. I can't lie, I threw myself pretty deep into the pool, I must say. Nearly drowned, but I survived. Introduction to the stats involved in machine learning. Revision of matrix algebra. Wow, bare matrices, yeah. I got my pen and paper out, started multiplying the matrices before I started writing it in Python. But yeah, introduction to PyTorch. Introduction to just in general deep learning, convolutional neural networks. There's so much going on there, different loss functions, biology as well, learning how the lungs function, how complicated the lungs bifurcate down all the way from your trachea down to the alveoli, graph theory as well, modeling the lungs as a graph. I'll make a YouTube video of my whole dissertation because I think it's cool, and I think it deserves its own video because it's wild. Yeah, that's basically it. That's the final year, and that's my whole degree. And just like that, I've graduated. That's it. Thank you very much for watching. If you have any questions, let me know. And other than that, thank you very much and bye bye.